Hi madam, we are the group 3 of D02 and we are going to present the assignment 2. So this is our group member and I'm Guang Yuan.
Hello, my name is Razin. I'm gonna doing question 1A, find the mean and median for each group of a data set. So I already put the data from Excel on the right hand side. So for mean day and night, pretty much you need to plus all of them and divide it by 9. It's because there is 9 data. So for the median, you need to arrange it on upwards. So I arrange it on upwards and then pick the middle one. So the middle one for median, my day is 113.6 and night is 121.6. Okay, that's all.
Hi, I'm Luqman. For question 1B, we are going to compute the standard deviation and coefficient of variation for each group of your dataset. So firstly, we are going to find the standard deviation for day shift. Following the standard deviation formula, we are going to find the variance first. So the variance of day shift will be the sigma, or total of data points, minus the the mean value of day shift power of 2 and divided by the number of sample size. So we got 487.4289 divided by 9. So the top is the variance equation in case you're having a hard time seeing them because on the last slide it's too small. So anyway, we are going to insert the variance into the standard deviation formula, square root the variance that we just got, and we got standard deviation for day shift, which are 7.3593. For the coefficient of variation for day shift, CV equals to the standard deviation of day shift, which we just got, divided by the mean value of day shift, 113.51, times 100, and we got the coefficient of variation for day shift, 6.48%. Next is the standard deviation for night shift. Same as before, we are going to find the variance first. So we calculate the sigma, or total of the data points, minus the mean value of night shift, power of 2, and divided by the number of sample size. And we got 3,541.3256 divided by 9. Below is the variance equation in case the above is hard to see. So anyway, we are going to insert the variance that we just got into the standard deviation formula, square root the variance, and we got the standard deviation for night shift, which is 19.8364. For the coefficient of variation, same as before, CV equals to the standard deviation of night shift, which we just got, divided by the mean value of night shift, 128.52 times 100, and we got the coefficient of variation for the night shift, 15.43. Now for question 1C, we are going to estimate 95% confidence interval of mean value for each group of the dataset. So we know the sample size n equals to 9. So we are going to find the critical value, which is the z value. Since we are estimating 95% confidence level with sample size less than 30, we are going to use the t distribution. So we are finding the significance level alpha equals to 100% minus 95%, which is equal to 5% or 0.05. And the degree of freedom df equals to sample size minus 1, which is 9 minus 1 equals to 8. So using degree of freedom 8 and significance level 0.05, we can find the z value in the t distribution table, which is 2.306. Next, we are going to find the margin of error, ME, using the formula for day shift, z value times standard deviation of day shift divided by square root number of sample size, and we got the margin of error for day shift, which is 5.6568. For night shift, same thing, z value times standard deviation of night shift divided by square root number of sample size, and we got the margin of error for night shift, which is 15.2476. Lastly, to calculate the confidence interval, we use the formula of mean value plus minus the margin of error to find the confidence level interval for day shift. For the lower bound, we take the day shift mean value minus the margin of error for day shift. And for upper bound, we take the day shift mean value plus the margin of error for day shift. And we got the confidence interval for day shift, which are between 107.85 to 119.17. For the confidence interval for night shift, we are also going to start with the lower bound. We take the night shift mean value minus the margin of error for night shift. And for upper bound, we take the night shift mean value plus the margin of error for night shift. And we got the confidence interval for night shift, which are between 113.27 to 143.77.
Question 1D. At 5 to 6 clinical levels, show the procedure of hypothesis testing to sample based on the following hypothesis statement. Does it say C, is there any evidence that the night shift is producing more tire per shift? So state the null alternate hypothesis. Hypothesis is a statement about the value of population parameter begin with assumption that null hypothesis is true, may or may not be rejected. So alternate hypothesis is the opposite of the null hypothesis. A statement that is accepted if the false data provide evidence that the null hypothesis is false. So for the null hypothesis, I got here HO, night is less than day. Night is less than or equal to day. Alternative hypothesis, night is more than day. So determine the critical value, single level. I got it from the question, 0.05 is 5%. So critical value, I got it from the formula. 9 plus 9 is the data. Minus 2 is the formula by 16. So if you look at the table, 0.05 and 16, you got 1.746. Step 3, calculate the t-statistic. S2P is the pool variant and you put it in the t-statistic, so you need to find it first. So S21 is the variant, S22 is the variant also, and 1 is the data. So, okay, I got it. I got the question, I got the answer is 223.82. So the t-statistic, just put it in there. X1 minus X2 is the mean, night minus day, I'm pretty sure. I got 2.13. So decision making is, since the test is 2.13, is more than 1.746. So you need to reject it. If it's more than 1.746, you need to accept the HO. So step 5, step 5, since HO is rejected, we can conclude that the night shift produce more tires per shift than the day shift. That's all.
Next, we are going to answer the question 2, and our group is responsible for the dataset C. This data provides a list of SMR of deaths from lung cancer for 25 groups of job among male employees, also given as smoking ratios for each job group. In this study, we would like to identify if the smoking ratio may influence the lung cancer SMR. And the table is the data date given by the question. So the question A, determine the dependent variable y and independent variable x for your datasets based on the description provided. So through the question, we found that the lung cancer SMR is the variable that we wish to explain. So it is the dependent variable y, and the smoking ratio is the variable that we use to explain the lung cancer SMR. So it is the independent variable x.
Hi, I'm Kurt. So for the question 2b, generate the simple linear regression model using as a function between dependent variable y and independent x. So down here is the simple linear regression model. More explanation will be on the next slide. Here is the video recording of what we do to get the answer for the question 2b. First, go to add-ins. Second, search for data analysis. Third, use XML analysis toolpath. Then you paste the input of x and y, and then you press enter to get the summary output, which is the simple linear regression model. Here is the video recording of what we do to get the answer for the question 2b. First, go to add-ins. Second, search for data analysis. Third, use XML analysis toolpath. Then you paste the input of x and y, and then you press enter to get the
Question C, determine the estimated regression equation for output in question B and interpret the coefficients. So through the summary output table, we found the B0 and B1, which is the intercept and the slope. After that, we insert the information and approximate the number to the equation y equal to B0 plus B1 x. We can find the answer, which is the lung cancer SMR equal to negative 2.85 plus 1.088 multiplied by the smoking ratio. And we interpret the coefficients. The lung cancer SMR is negative 2.885 when smoking ratio is 0. For every additional unit of smoking ratio, the lung cancer SMR will increase for 1.088. Question D. Determine the coefficient of correlation from output in question B and interpret the value. Through the summary output table, we found the coefficient of correlation R, which is the multiple R, equal to 0.7162 equal to 71.62%. It indicates a strong positive relationship between the lung cancer SMR and the smoking ratio. Question E. Determine the coefficient of determination from output in question B and interpret the value. So through the summary output table, we found the coefficient of determination, which is the R square equal to 0.512999 equal to 51.30%. That is 51.30% of the total variation in the lung cancer SMR is explained by the variation in the smoking ratio. The balance of 48.7% is the unexplained variation.
For the question 2f, can we infer that dependent variable has a significant association with the independent variable? As you can see on the table, the p-value is 5.66 times 10 the power of negative 5, which is almost 0, is smaller than a equal to 0.05. Thus, reject HO, the model is valid and significant. There is a significant association between smoking ratio and lung cancer SMR. For question 2g, graph the relationship between the two variables as a scatter plot. Discuss the relationship of the variable based on the spread on a straight line of the scatter plot. So the interpretation of the graph is the bigger the smoking ratio, the lung cancer SMR ratio will be higher. Next, a linear model is suitable to reflect the relationship between lung cancer SMR and the smoking ratio. Lastly, the relationship also appears to be as strong as the data reveal a clear and predictable pattern.
So that's all of our presentation. Thank you.